Alright, this video we are talking about the domain and range of functions. We talked about this a little bit in a note when we first started talking about functions, but we're going to go into a little bit more detail with it in this video. I have a graph here and it says determine the domain and range given the graph of the function or relation. So this is not necessarily a function, it's a relation, but they still want us to talk about the domain and the range. So the domain, if you remember this from any previous lesson, the domain is the x values of the points in the graph. So if we think about this, the x values come from the x-axis. So on this, it looks like this shape, the farthest out it goes from out to 1, 2, 3, 4. Negative 4 is a boundary right there on x. Doesn't go past that. And then to 1, 2, 3, 4 positive boundary on this. So the x values are going to be between negative 4 and positive 4. Now we want to express that in interval notation. If you remember how to do that, it's brackets, negative 4 to positive 4. So that would be the domain of this function. So let's talk about the range also. Now we remember the range is the y values of the function. So let's look and see the y-axis here. We have the y-axis. And my graph here, this relation, it goes up to 1, 2, 3, 4, 5, 6, maximum of positive 6 on the y-axis, and then this goes down 6, I think. 1, 2, 3, 4, 5, 6. So in the range, our values are on the y. So between negative 6 and positive 6. So in interval notation, that would be from negative 6 to positive 6, including those endpoints. So domain is the x values, range is the y values. Let's try another. Here we just have a line, and this is a function because it would pass the vertical line test, so this one is a function. Let's talk about the domain first. Now on this one, the x values, that's the x-axis, we look at that. My arrow points forever in that direction towards negative infinity. And it keeps going down forever. So that line will never end in both directions. So the domain, the x values, is going to be between negative infinity and positive infinity, so all real numbers. The range would also be the same thing, because if you look, if it's going forever up, then the y value will keep increasing. If it's going forever down, the y value will keep decreasing. So the range is between negative infinity and positive infinity there also. You would describe this by saying the domain is all real numbers and the range is all real numbers. Alright, we have a quadratic function here. This is a function. If I were to pass vertical lines through it, it would pass the vertical line test. Let's talk about the x and y values here. The domain, first of all. Now, as you see, the domain comes from the x-axis and x value. Since this is going forever to the left, it's got an arrow there. Forever to the right, it's got an arrow there. The x values, as this thing gets bigger, it's going to spread out and get larger and larger. Your x values will grow in both directions. So the domain of this function is from negative infinity to positive infinity. No restrictions on the x values. However, on the range values, it's a little different. If you notice your values of y, it seems that this vertex point on this graph seems to be the lowest point in y that you ever have. So what y value is that? Well, it's 1, 2, 3 units down on the y-axis. So that starts at negative 3. However, as you can tell, since you've got the arrows up on both directions, it's going to keep getting bigger and bigger and bigger. So we start at negative 3 and go to positive infinity. They do grow from forever going upward. But negative 3, as you can tell from the graph, is the lowest y value you'll ever have in that graph. Now, in algebra study of functions, you really only run into 3 different types of functions that you have to be leery of, or you have to kind of know about when you're trying to describe the domain. If you have a polynomial function, polynomial functions will be like you have x to some power, you have terms added like example 1 here, 2x squared minus 9x. Notice there's no fraction bar, there's no division of anything, there's no square root symbol in there, nothing like that that's messing it up. It's just a straight polynomial function. The domain of a polynomial function is always all real numbers. To represent that, we'll say the domain is from negative infinity to positive infinity. Now, I can't just say what the range is of the function unless I first get a graphical representation of it. So I would kind of need a graph of this function to be able to tell you what the range is. But we could find the domain without actually having the graph. All right, let's talk about the domain of this function, f of x over x squared minus 16. Now, the second type function you kind of have to watch out for is the rational functions. Rational functions have a denominator. And what we learned from way long ago in arithmetic is that the denominator of a fraction can never be equal to 0. So if you have that situation show up, what we need to do to restrict the domain is take the denominator and set it equal to 0, or in other words, set it not equal to 0. So in this problem, x squared minus 16, we know cannot equal 0. So I need to solve this equation. So I'm going to just add the 16 to the other side. So x squared is not equal to 16. And then use the square root property and take the square root of both sides. So x is not equal to, if you remember this from earlier lessons, when you take the square root property, you do the plus and minus, square root of 16, which is 4. So the domain of this function says x can be anything except 4 and negative 4. And that's a really good way of describing the domain there. Just say x cannot be, or x is not equal to 4 or negative 4. Now, one thing you could is write that in interval notation as well. So we could say that the domain is from negative infinity up to negative 4, union, and so we could pick up, we're not equal to negative 4 because we got the parentheses there. Go to negative 4 to positive 4, parentheses again because we're not equal to, and then union from 4 to infinity. That's a way that you could express that domain in interval notation. The third type of function that you have to watch out for in algebra is the radical functions. One thing we learned when we studied about radicals is whatever's underneath the radical cannot be negative. So to restrict the domain, we have to keep that idea in mind. Whatever's under the radical, otherwise called the radicand, cannot be negative. So if we want it to not be negative, that means it can be 0 or bigger. So to restrict the domain, you take whatever's under the radical, so in this case 2x plus 7, and you're going to say that it has to be either greater than or equal to 0. So we're going to describe this with an inequality here. Whatever's under a radical has to be positive, so it's got to be greater than or equal to 0. So I'm just going to solve this inequality. We're going to subtract 7 from both sides. Then divide by 2. So x has got to be greater than or equal to negative 7 halves. So that's one way you could describe it, or we could do the interval notation and say from negative 7 halves to infinity. Sometimes in a function you may have more than one thing happening, more than one thing you have to pay attention to. For example, in this number 4 example, we have a square root on top, and we have a denominator also that has to be restricted. So let's do the parts separately and then see if we can put them together for one statement about the domain. So the first part I'm going to look at is the numerator, the square root of 4x minus 1. So 4x minus 1 I know has to be greater than or equal to 0. So let's solve that inequality. If I add the 1 to both sides, then divide by 4, x is greater than or equal to 1/4. Now also, we know that the denominator cannot equal 0, so x minus 6 cannot equal 0. If I solve that, then we know x is not equal to positive 6. So if you think about this, on the number line, first of all, before it can be in the domain of our function, we know it's got to be 1/4 or greater. So that's everything to infinity, except we run into a roadblock down here at 6. We know we can't be equal to 6, so we're going to have a hole there. So the domain of this function would start out at 1/4, go up to 6, not to be included, union, and then from 6 to infinity. So you have more than one thing you have to pay attention to in that function to describe its domain. Again, it would be very difficult to figure out the range of the function unless you've had a graph first. So